Okay, so welcome and let us begin the problem number 4 of recitation 3. I'll briefly elaborate what the problem is. So here is a 4-bar mechanism and we have revolute joint, revolute joint, revolute joint, and over here we have prismatic joint. And we have been given certain parameters and we need to find remaining parameters. I'll further explain which are which parameters, and let me go ahead and start with the first approach. So first approach is a very conventional one where we have four vectors, that is R1, here we have R2, here we have R3, and here we have R4. If I have to write the values of these parameters, then R1 is my AD, R2 is AB, R3 is B and C, R4 is C and D. So value of R1, that is AD, value of AB, R1 is AD and AD is 1.7, AB is 0.9, BC, that is actually unknown, then R4 is also unknown. Theta 1 is 6 degrees, this is phi plus theta 1, that is 120 plus 6, and that is 126 degrees. So phi is given as 120, theta 3 is unknown, and theta 4 is also unknown. Yeah, so if, yeah, that is right. So we have four unknowns over here, and we have two equations from the vector loop. We have four, let me go ahead and let me say we have four unknowns in this case. But let me propose you another method where I'm saying that this is my R1, this is my R2, this is my R3 dash, and this will be my R4 dash. In this case, I have R3 dash, R4 dash. Theta 3 is actually equal to theta 3 dash, and theta 4 is different from theta 4. So I'm just going to write theta 4 dash. Value of R1 is still same, 1.7, R2 is still same, 0.9, and R3 dash is unknown. R4 is that we know actually this time, and that will be H 4.8. Value of theta 1 6, theta 2 that is 126 degrees, that I can say from the left hand side, and theta 3 is still unknown, and theta 4, for theta 4 what we can do is, let's say I have a triangle which does look like this, and this is horizontal, this one also horizontal. This is my theta 3, this one will also be theta 3 because this is horizontal, and this angle is actually theta 4 dash. This is theta 4 dash, this is pi minus theta 4 dash, this is 90. So summation of three angles of triangle is 180 degree, that is pi. So now I can write pi minus theta 4 dash plus pi by 2 plus theta 3 is equal to pi. Pi is will be cancelled out. Theta 4 dash is equal to pi by 2 plus theta 3, which I can write over here pi by 2 plus theta 3. So now you can see we have two unknowns. We have three unknowns and we have three equations. We have, sorry, we have three unknowns in this case. And if I write my vector loop equation, that will be R1 plus R4 dash is equal to R2 plus R3 dash. So these are actually two equations in, that is x and y, and I have third equation, that is third equation is this, theta 4 dash is equal to pi by 2 plus theta 3. So we have three unknowns and we have three equations. So we are gonna proceed ahead and solve this equation. So before I begin solving this vector loop, I'm gonna do some rearrangement, and that will be r1 minus r2 is equal to r3 dash minus r4 dash. You will realize why I did this sort of arrangement. So I'm gonna write x direction, and that is r1 cos theta 1 minus r2 cos theta 2 is equal to r3 dash cos theta 3 minus 4 dash cos theta 4. But here we know the value of theta 4 dash, that is equal to pi by 2 plus theta 3. So right hand side will look like something this, 3 cos theta 3 plus r4 dash sin theta 3, and left hand side will be still the same. So I'm gonna say, and this is my equation 1. Why? Then I'm gonna go ahead and write my second equation, that will be with the y. r1 sine theta 1 minus r2 sine theta 2 is equal to r3 sine theta 3 and r4 dash sine theta 4 dash. Theta 4 dash is again pi by 2 plus theta 3. So my equation will turn out as sine theta 3 minus r4 dash cos of theta 3. And left hand side will remain same. Here is my second equation. Now, in order to, so we have two unknowns for these two equations, those that is r3 and theta 3. Now let us eliminate theta 3. We can do that by squaring and adding first and second equation. So that will lead, if I do this operation, the final equation that I would get will be, I'm not gonna go into the detailed steps which you can do do on your own. So r1 square is equal to r2 square minus r4 dash square to r1 r2 cos of theta 1 minus theta 2. Now value, so if you evaluate this equation, the value of r3 dash will be 2.14. You have to replace these values as those are given on the right hand side, which is this. You have to put up the values of r1, these parameters from the right hand side of the table, and the answer that you are going to get for r3 dash is 2.4. Now let us calculate the value of theta 3, and what we can do for that is we can take this equation here and we can solve it for theta 3. So I'm going to write r1 cos theta 1 minus r2 cos theta 2, that is 2.14 cos theta 3 plus 2.14 sin theta. Now I'm going to convert it into half angle formula, and that will be tan theta 3 by 2 will be equal to t. And now if I write it for cos theta 3, then it will be 1 minus t square by 1 plus t square, and sine theta 3 will be 2t upon 1 plus t square. And if I put this, substitute this value again back in this, then I'll get an equation which will look like this: t square minus 2r4 dash t plus a minus r3 dash is equal to 0. And value of a will be r1 cos theta 1 minus r2 cos theta 2. So that is quadratic equation. I'll get two solutions, t1 and t2. So value of t will be the solution of quadratic equation, that is r dash plus beta. So remember, you can have beta is equal to plus or minus 1, r dash 4 square minus a square plus r3 dash square, and by a plus r3 dash. I'm not going to dwell upon how did I get this equation, but if you would do a few more steps and you will get the same answer. And I'll, now I'm going to write down value of t1, which I'll get after substituting all the values. T1 is 307 and T2 over here will be 0.0597. Based on that, I'll get tan theta 3. One of the possibility will be 34.13 degrees, and the other possibility will be, other solution will be 6.83. Now I must verify by keeping this solution into the second equation and see which one is correct. So here is the second equation. So I'm going to paste it over here, and I'll replace my value of theta 3 and r3. So right hand side, okay, so left hand side of this equation is r1 sine theta 1 minus r2 sine theta 2. So you already know r1 1.7, 1.7 sine 6 degrees minus 0.9 sine 126 degree. Value of this is equal to minus 0.0 minus 0.5504. Now let's say theta 3 is 34.13. Let us evaluate RHS in this case. So which will be R3 dash minus sine into sine theta 3 dash minus R4 dash cos 3. So if you replace the value of theta 3 as 34.13, this will come out as 0.5385, and which is not equal to this value, that is minus of 0.5504. So I'm gonna go ahead and write my solution as 6.83, and I would recommend you to verify this value for the equation and you will get the same answer. So we have r3 is equal to 2.14 and theta 3 is equal to 6.83. Now we have to find the value of r4 and theta 4. So I'm gonna go and write this equation, copy this figure again, and let us work on finding the value of r4 and theta 4. Okay, so that is, so this is my r3 dash, and this is my r3 minus r3 dash. So that is 2.6 minus 2.14, and that will be 0.44. Value of h is 0.8. So this is my r4. So r4, we can write Pythagoras theorem. R4 square is equal to r3, because this is 90 degrees over here, r3 minus r3 dash square plus h square. And if you replace values of all this into the equation, you will get value of r4 as 0.923. Now let us find the value. Just a second. Value of theta 4. I'm gonna go and paste this image again. Okay. So I'm gonna make a triangle over here. So this angle is theta 3. This angle over here is theta 4. And this angle, let me call it as phi. So I do know this is R3 minus R3 dash, that is h. So value of phi, so remember this angle is phi. Phi is equal to tan inverse h upon R3 minus R3 dash. So if I go ahead and write summation of three angles of triangles, and it will be theta 3 plus phi plus phi minus theta 4, that is phi. Theta 4 is equal to theta 3 plus phi. Theta 3 is 6.83, which I already know, plus tan inverse h by r3 minus r3 dash. H is 0.8 and value of this is 0.44. So if I do that, I can find the value of theta 4, and that will be 66.93 degrees. Okay, so let me stop here with the solution and go ahead with the SolidWorks illustration. So I do already have a sketch that is prepared for this problem, and if you analyze this, you can see the lines are exactly same as given, that is 0.9, 2.6, 120 degrees. Over here that is 6 degree, 1.7, and we found the solution of theta 4 as 66.93, so it is pretty close. And the theta 4 dash, we found it as, that was theta 3 plus pi by 2. So theta 3 was 6.8, I reckon, and that is equal, that is added, and after adding pi by 2 it will be around this value. So we can say that the solution is verified. That is zero point 0.8. Yeah, so you can see that the values are pretty close, and I'm gonna go ahead and stop the recording.